Next example comes out of section 10.3, composite functions, and it's our word problem. In this word problem, we're inflating a spherical balloon, a gigantic spherical balloon. Apparently it's like a weather balloon or something, and we're given this equation that r equals the square root of t, where radius is in feet and time is in minutes. Not exactly our normal meters per second SI units, but will work anyway. So radius equals square root of time. Express the volume as a function of time, the key here being volume. If you were given this question on diploma, they wouldn't actually expect that you know the volume of the sphere off the top of your head. There are some things that they expect you to know, areas of boxes, areas of circles, circumference, perimeter, that type of thing. But if you're asked something very specific like this, even in calculus, you would be given the fact that volume is a function of radius. Volume equals 4 over 3 pi r cubed is the equation of the volume of a sphere with respect to its radius. So, but we know that r equals the square root of t. So we can rewrite this volume as volume equals 4 over 3 pi times the square root of t cubed. Instead, replace the r with root t. If you like to tidy that up a little bit, not have a square root and an exponent, you can write that as 4/3 pi t to the 3 over 2. Those are the same thing, equivalent expressions that would be volume as a function of time. So we've got this part. Now the follow-up question to that is just to say, when does that equal 6,000? So 6,000 cubic feet is equal to 4 over 3 times pi times t to the 3 over 2. Most of my students here will do a fairly good job of this algebraically. Some of you will just graph it right away and graph y equals 6,000, y equals 4/3 pi x to the 3 over 2 and find where they intersect, and that'll work perfectly fine, especially in a numerical response or multiple choice question. To do this algebraically, you can multiply by 3, divide by 4, divide by pi, but any way you look at it, you're going to have 6,000 divided by this number here, 4 pi over 3, is equal to t to the 3 over 2. This is where algebraically a lot of, at least my students, will get stumped with this sometimes, and that is just remembering their exponent rules. The best way to get yourself just to t here is to say, okay, well, then raise both sides to the 2 over 3, this to the 2 over 3. The reason why that's useful is that t to the 3 over 2 to the 2 over 3 just gives you t to the power of 1, t to the exponent 1, or just t. Now the other part is just number crunching. I don't expect any of you to be able to do 6,000 divided by 4 pi over 3 to the 2/3 in your head, but the answer here ends up being approximately 127 minutes were the units of time in this particular question. So, however this gigantic weather balloon is being inflated, that its radius is equal to the square root of time, it would take 127 minutes after starting to inflate it for it to be 6,000 cubic feet. So, not something I've done a lot in my life, but still a somewhat useful application of composite functions.